Hello everyone, so welcome to this video. So we will be starting the system design video and we will not directly dive into the system design. So we will start with some general terms, some basics, and then we will go ahead. So first of all, let us discuss a single server setup. So what is a single server setup? So for example, this is our user. It can be a web application, a mobile application, or maybe a third party client, and this is our server, web server, right? This is the most basic client server architecture we can have, and we can also add some DNS. So this is domain name service. I'll just write it. This is domain name service. So what happens? So for example, our user enter some site, some abc dot com, anything like that. The domain name servers finds the respective IP address for that, finds the respective IP address for that uh, website, and it returns it here. Then with that IP, the user calls this server and it returns a response, a HTML page, a HTML response. Yeah. So what happens? The traffic of your web server comes from two sources. It can come from a web application, it can come from a mobile application. So in mobile application, the HTTP protocol is the communication protocol, right? And we can get a JSON as a return. So for example, we did a get call at this API user with the ID 2 or 12. So what this says, key receive user object for ID 12, receive user object for ID 12. So it will return some JSON with ID 12. It will have some, for example, name field, ABC, and there will be more fields. There can be more fields. So this is the most basic client server architecture. Now we see a problem here. A web server cannot handle a lot of traffic, and with the growth of the user base, this one server is not enough. So we need multiple servers, as well as we need a database as well. So we can go ahead and so we can go ahead and have something like a user. We can have a user, the same diagram we had for the previous one. It is the CDN, sorry, not CDN, but DNS. CDN is a different thing. I hope so. Before I also, yeah, DNS. And then we will have a server and we will have a DB. We will have a DB here, right? Now what this does, we have some separation of concerns. So database will hold all the data related to our business, what we need. So maybe for example, it is a ERP system, so it will hold all the data related to students. If this is a student ERP system, there might be teachers as well. And this is our web server, the backend server. It will hold all the business logic or all the logics that needs to be processed. Now the question is, you might know there are SQL database and no SQL database. Now which database to use? First of all, let's discuss on SQL. uh, the values are represented in tables and in the form of rows and columns. We can perform joins here. Now no SQL database, the values are values are stored as key value pairs, or we can say key value store, graph store, document store, then column store. and we cannot perform joins on them. Now this SQL is easy to use, and we have been using it for last past a lot of years. But we can use the NoSQL database when we require, first of all, low latency super low latency. Second, we have unstructured data. So you saw before I present some JSON, so uh, we need to work with this unstructured data, or we only need to serialize and deserialize the data. I'm not writing the whole spelling. Or we need to store a massive amount of data. Now the next concept we will be looking into is vertical. Okay, this color is not good. So vertical scaling and horizontal scaling. So what is vertical scaling? It is scale up. As the name suggests, scale up. It means we increase the power increase the power. What does this mean? We increase RAM, we increase the CPU extra, right? Now horizontal scaling is scale out. Here what we do, if we have one server, we attached multiple server to it, or multiple db. If we have one db, we attached multiple dbs to it. So we have this distributed network of server or dbs. So that is what we say horizontal scaling. Now when traffic is low, vertical scaling is a good option. Low traffic, vertical scaling is a good option. Low traffic, vertical scaling is a good option. But vertical scaling has and it is its main advantages, but vertical scaling has some serious limitation. First of all, imagine we have this one server or one db, and for some reason uh, this goes down, and we have like vertical scale, we had it like somewhere around 100 TB, 128 GBs of RAM. We have a very high spec server, but for some reason it fails. Now what happens? Our service is down, right? So we have a single point of failure here. Single point of failure. So we have single point of failure here. Second thing, since this 100 TB was imaginary number, we cannot like scale unlimitedly. So what that mean, in future, if this server is not able to serve and we need to move ahead, we cannot scale up every time, like from 128 we go to 256 GBs of RAM, then 1 GB of sorry, not 1 GB, 1 TB of RAM and everything. So that is also not possible. So then comes our horizontal scaling. It is very much desirable for large scale applications. Horizontal scaling is very much desirable for large scale applications. Yeah. So we generally go ahead with horizontal scaling even if we have multiple servers. So even if this one fails, we still have these two to serve the request, right? Okay, now let's move ahead. If there is a user and this is our server, our server can hold 100, it can serve 100 requests per minute if we say. And this user are like is hitting the server, hitting the server, hitting the server, and it has hit like 100 request or 99 100 request we say for one past minute. So now what will happen, either our server is overloaded with the request, it will be slower, it might also not return any response back, there might might be throttling. So we cannot just put all our load on one server as well. So for that, and so we have a load balancer to handle this. So what does a load balancer do? It distributes the incoming traffic among web servers. And how does it distribute? It is defined in somewhere in the load balancer sets. So we have this user, it makes some calls, it goes to the load balancer. So this is our load balancer, we have some servers. So this load balancer will, so for example we have 10 requests. In an ideal case, the load balancer will route 5 requests to this server and 5 requests to this server in an ideal case. Okay, this is the user. Now what happens, the user connects with the load balancer with the public API, with the public API. Okay, this API we are not able to access the servers, so these are the server layer servers, and the load balancer interacts with the servers with the private API. With the addition of the load balancer, we are not directly hitting our servers, so we have the load balancer, and uh, which is our servers are accessed by this private API, so it also acts as a security layer as well. So now what happens, let us consider some scenarios. If for example this server 1 goes down, if the server 1 goes down, all the traffic will be routed to server 2. And what happens, this prevents our website from going down or going offline. If we just have one single server and it goes down, then everything is over. And if the traffic grows rapidly and two servers cannot handle it, we can additionally add one more server, and it will automatically distribute the traffic to this third server as well. Now there is a very good concept. So we have database replication. So what is database replication? For example, we just had 1 DB. So database replication can be used in the data management system, usually with we have a master slave relationship here, right? So we have a master slave relationship between the original. So this is the original and this is the copy. Now what happens, all the write operation happens in general to the master, and all the read operations are done through the slave, right? So all the data modifying commands like insert, delete or update must be sent to the master database. So since most application have get command or read APIs more than write, we have multiple number of slaves than masters. Okay, so what is the benefit of having this? So let's just go ahead, and for example this is our web server, this is our master DB. I will write it as M. So all the write happens here, and these are our slaves, 1 slave, 2 slaves, 3 slaves. Okay, these are also connected, right? So with this we have better performance. First of all, we have a better performance since all the writes will happen here and all the read will happen from here. So we have a better performance and everything will be processed in parallel. So we have a reliability. If our one of our database is destroyed, uh, then the data, we still have the database, we still have the data in another database. So for example, this db is somewhere in Japan, this is somewhere in Europe, this is somewhere in Asia. So this is also, but this is somewhere in Asia, and we have another db, it is somewhere in America. Due to some reason, for example, in Europe or somewhere, or for example, we take America, there is a cyclone or a typhoon and the db gets destroyed, but we will still have data in rest of the 3 dbs. So it is reliable and we will have a high availability as well. So now let us consider some scenarios. Scenario 1, if we have just one slave db, if we have just one slave db and it goes down and it goes down, so what will happen, read operation will also be redirected to the master. It also redirected to master. Then we have another scenario. If master goes offline, if master goes offline, then what happens? So if the our master node goes, our master db goes offline, then a slave database will be promoted to the new master. Then what happens, slave promoted to new master. Okay, and all the database operation will be temporarily executed in on the new master database. And there we will have a new slave, we will have a new slave to replace the old one for the data replication immediately. So what happens, in production database, promoting a new master is more complicated as the data in the slave database might be out of sync. So what happens, we have a master database, so here this one will always be in sync, so data will always be in sync. But these replicas, the slave one, the data is get updated in back, so async updation happens here. This is always in sync. So when one of these replicas becomes our master, when this is out of action, so we don't have some data issue, so we generally like write data running script, data running or data recovery scripts. Although there are other methods as well, like multi-master and circular replication. We will discuss about these later on, but for now on, let's assume we write some data recovery scripts. So our final design will look something like this. So this is our user, this is our user, this is the DNS, this is our load balancer. I'll just write everything later. I'll not make more dbs here. So this is my load balancer, this is my server 1, this is my server 2, and this is my db1 or master db. I'll write mdb, and this is slave db as db. Request goes, DNS returns the IP, load balancer balances the load. All the write happens on the master and all the read happens from the this one. So this will look like our final thing. Now we can also improve load response time. So every time we will have to query our DB, get the data from the DB, then we will return and everything like that. So we have something called cache, right? We have something called cache, but before cache, we can discuss something like a CDN. CDN is content delivery network. Content delivery network. So content delivery network, what it does, we have all the static content in these CDNs only. Static content in the CDN. So what happens, our request comes, if there is any static content that needs to be served, it is served by CDN only. CDN is also, there is also replication in the CDN. So the CDN servers will be distributed across the world. These are POPs, point of presence. We also call them edge servers. So if a user makes a request from this point, the closest server is this one, so it will return the data to this user. And the IP address, if I remember correctly, the IP address of all these edge servers are same. Okay, so I think the video has gone quite big this time, so we will keep it here. In the next video we will discuss cache. In the next video we will discuss cache. We will go deeper into CDN. We will we will go deeper into CDN. We will discuss stateful and stateless architecture. We will discuss data centers, message queue, log matrix automation, and database scaling. Yeah, this is what we will be doing in the next video. So do look out for that, and please subscribe to this channel. Thank you.